that you see?
4.
So we're going to divide each of these by 2x to the fourth. Put that on the outside. Now, if it's the same on the top and bottom, like 2 divided by 2 is the same, it just goes away, it becomes a 1. When you have something like x to the sixth over x to the 4, you're subtracting the exponents. 6 minus 4 is 2. All right, middle one here. What is 14 divided by 2?
7.
7. And then x to the fifth over x to the fourth becomes x to the 5 minus 4, which is 1. And then 16x to the fourth over 2x to the fourth. What does that become? What is
Negative 8.
8? Good. Okay. And the x to the fourth over x to the fourth goes away because it's the same. It's the same on the top and bottom. Just think of it as going away.
So it would just stay negative 8, not 8x.
Yes. There's no, yeah, there's no x because think about it this way. When you subtract 4 minus 4, what does that become?
Just x by itself.
0. 4 minus 4 is 0. Anything to the 0 power is just 1.
Okay.
Somehow you've got to spend some time reviewing our last lesson, or, I can say it again, but like this stuff's got to be clear. It really does. We've got some more practice ahead today. That will help.
Okay.
Okay, so now you're looking for two numbers that multiply to -8. So multiply to -8, but adds to 7. Can you think real hard, or as hard as you can, and maybe give me those numbers, please?
Adds to 7. Mm,
The multiply to -8 is the one to start with, not the adds to 7. There's actually an infinite
oh,
number of numbers that adds to 7.
so it would be -4 times 2.
Okay, so does that add to 7?
Oh,
Nope. So that one's out. There is a combination. It's not impossible.
-1 times 8.
Okay, that does work. So this becomes x minus 1, x plus 8. Is that okay?
Yeah.
All right. Okay, so let's keep going here. So we're going to talk about how to do grouping problems. So this is somewhat related to what we've done prior. You'll do a little bit of GCF work here. So the thing that you should look for is that there's no number that goes into like 6, 13, and 6. There's no number. No. All right. So then the strategy here is to take the 6 in front and the 6 in back and you multiply those together, which is 36. Okay. So now you're looking for two numbers that multiply to 36, but they have to add to 13. Multiply to 36, but add to 13. So think about numbers that multiply to 36 first.
6 and 6. 1 and 36.
Okay.
Um,
It's better if you do it in order, like 1 and 36, 2 and some number, 3 and some number. 4n some number and so on. Like
Um,
you're doing it sort of sequentially,
2 and 18,
right?
and then
And you're welcome
3,
to use a calculator. Like don't feel like you got to do this by hand.
3 and 12,
Okay. How about 4 and
4 and 9,
okay? Do any of these add up to 13?
the 4 and 9.
4 and 9. Okay. So we're going to break this 13y apart into 4y plus 9y. And then we're going to bring the other stuff down. Is that okay?
Yes.
Okay. Now, the reason we do all this is because we now find the GCF between the first two terms. What goes into both 6 and 4, and then what's the smaller exponent between y squared and y?
They could be divided by 2y.
2y, yes. So we're going to divide each of these by 2y. So remember I said you get another chance to work on that. These are a little bit easier than previous rounds. What is 6 divided by 2?
3y,
That becomes 3y. And then how about 4y over 2y? What does that become?
2y,
Why is the letter y still there? Why does it remain in this case?
because they both have y.
Okay, but we said if they both have it, it goes away.
Oh, yeah.
You
So it would
got to
just be,
remember that, like that second time now, and it's really important. Not for me, for you. Like you can do this absolutely. All right, so this is really important now. The the thing you just put in parentheses goes in parentheses again. You just copy it over, and then you're trying to figure out what goes in here before it, such that when you multiply in, you get back to 9y plus 6. So look at either the number, like what do you multiply 2 by to get back to 6? Or what do you multiply 3y by to get to 9y? What is that?
so 2 times 3 for 6, and then 3 times 3 for 9.
It's got to be the same number. So is there a number that multiplies 3y to get back to 9y and 2 to get back to 6?
3.
Plus 3, yeah. Okay, so now you take what's inside parentheses and you factor it out again. Does that make sense?
Yes.
And then you bring down the 2y and the plus 3. And that's your final answer. So there's actually not that much work. There's just a lot of like moving parts, steps to
Yeah.
doing this. So the challenge isn't really, it's coming up with the answers to each of the individual steps. So we'll look at 11 here together. Any questions though before we move on to that?
No.
Okay. All right. So again, this is not like a situation where you're going to be able to find a GCF. There's no number that goes into 9, 18, and 8. So you multiply the 9 and the 8, positive 8. So 9 times 8 is 72. And now you're trying to find two numbers that multiply to 72, but add to positive 18. And the best way to do it is to start at 1 and then keep going down the list here until you find something that works. And that's where you grab your calculator and you say, okay, what is 72? 72 divided by 2. that number there. What is 72 divided by 3? Put that number there. They've got to be whole numbers. They can't be fractions.
Okay. 6 and 12.
It is 6 and 12. So we're going to break this apart and do 6y plus 12y. Bring the other stuff down. Okay, and now you've got to find the GCF between the first two. Like what goes into both 9 and 6?
Um,
And
3.
what's the small? Yeah, 3. And then between y squared and y, it's 3y. Okay, so try really hard. Remember what we did in the last problem. What goes in parentheses when you divide each of those by 3y?
Mm, Divided 9 and 3. What?
Yep, divide 9y squared by 3y and then 6y by 3y.
So it'll be 3y plus 2.
Good. And then that goes in parentheses here. So now you got to figure out what goes here such that when you multiply in, you get back to the previous line.
Would it be plus 4?
Plus 4, good. And then you take the thing that you had in parentheses out of both and you bring down the other stuff. What
Okay.
questions do you have at this point?
Um,
What would keep you from being able to do this on your own?
I just had to remember to like move stuff around and then what goes into both numbers for the next step. You get the answer?
Okay. Yeah, so we're going to do one more together and then we'll move on to new stuff. You definitely want to practice these on your own.
Okay.
Like even though we've done them, you can certainly just not look at the video, pause the video, look at your notes. Okay, so this one's a little bit more difficult. You have to multiply 8 by minus 9. So 8 times minus 9 is minus 72. Okay. And then you have to figure out two numbers that multiply to negative 72, multiply to negative 72, but they add positive 6. Now, this time it's one positive and one negative.
Okay.
And then negative 2 and 36, 2 and negative 36. So there's always going to be like both numbers, one positive, one negative. So will you keep going down this list? They have to add to 6.
Okay.
How are you doing on this one?
I'm getting closer to running out with sixes. So it'd be -6 and +12.
Yeah. So we're going to split this apart into -6z plus 12z minus 9, bring the 8z squared down. And then you again look at the first two. For this time, you're dividing by 2z. So that's 2z on the outside. Tell me what goes on the inside, please.
So it'd be um 4z.
Okay, so
Um,
I agree with the 4z plus or minus.
um, plus -3.
Okay, minus 3. So now put 4z minus 3 in parentheses over here and figure out what goes in parentheses. Or I'm sorry, what goes outside the parentheses such that when you multiply in, you get back to the previous line. Like, what do you multiply 4 by to get 12? What do you multiply 3 by to get the 9?
Oh, okay. Um, wouldn't it be 3?
It would be 3 plus 3. So now the next line, you take what you wrote in parentheses and you bring down the 2z and the plus 3. Is that clear?
Yeah.
Okay. All right. So next grouping of problems is what's called difference of squares. We're going to look at a couple of practice problems before we get to the ones that are on your paper there. Let's say it was x squared minus 16. This becomes x minus 4, x plus 4. Let's say it was x squared minus 49. This becomes x minus 7, x plus 7. So have you seen this before?
Yes.
Okay, so the formula here, and the formulas are a good thing, is that if it's a squared minus b squared, it becomes a minus b times a plus b. Now you have to figure out like what is it that you're squaring to get back to the previous line. And I think that's where most students struggle is they don't recognize that. I'll give you an example here. Let's say it's a 9x squared minus 25y squared. You have to figure out what it is that you're squaring. And that's your A. Like whatever's in parentheses your A, whatever's in parentheses your B. How do you get back to 9? Like what do you square to get to 9? What do you square to get to x squared? Any idea?
So it'd be the 3, 3.
3 definitely gets you to 9. How about to the x squared?
Um, I'm not sure.
3x. 3x. So 3x squared means 3x times 3x. And the 3 times the 3 gets you to the 9. X times x is the x squared. That's why it becomes 9x squared. So tell me what would go in parentheses over here. How would you get to 25y squared? What would you put in parentheses to square to get back to that?
5x.
But it's a y this time.
I mean 5y. Sorry.
5y. Good. So your A is really 3x and your B is really 5y. Is that okay?
Yeah.
All right. So you've just got to follow this format here. A minus B, A plus B. So whatever your A is, whatever your B is, you're just going to replace here. So could you tell me what A minus B becomes in this example?
So the um
What,
x
3x?
minus 5y.
Okay, that works. And for the next one,
Um, mm,
what's the
minus
A? What's the value of A?
3x
3x. And what's the value of B?
plus 5y.
Yes. Okay, so now we're ready to try some of your problems. All right, so here we go. So it's kind of like the previous problem. You got to figure out what squared gets you back to the previous line.
Would be 8x
8x, good. And what gets you back to 9?
um
What do you
3.
square? Yeah, you square 3 to get back to 9. So your A is the 8x and your B is 3. What does this become?
Would be 8x minus 3,
Okay,
and then 8x plus 3.
okay, very good. All right, so I'm going to help out a little bit with the next one. All right, so the first one here is all on you. What do you put inside parentheses here to get back to this?
2s.
Very good. And the one on the right here is 7t squared. Now the 7 probably makes sense. 7 squared is 49. When you square a t squared, that's you get back to t to the fourth. Is that okay?
Yeah.
Okay. Can you tell me what to write here?
Um 2s minus 7t squared.
Good. What else?
And then 2s plus 7t squared.
Good. Any questions on that before we move on?
No.
Okay. 15 seems really out of place unless, let me check something real quick. Uh, Sorry, I'm still just trying to get to the right place. Everything is slower this late in the day. right. So yeah, that's what I thought. All right, so this one, I don't know why this one is here, but not everything factors, and 15 is an example of one that does not factor. So if it does not factor, you're supposed to write, that means it's prime. Have you heard that before from in class?
Yeah.
Okay. All right. So we're definitely going to finish 16 and 17. So I don't know if you can quickly send over another page. Be faster than me looking through the bookings to find it.
Okay.
I'm actually going to finally make a note to remove that from the bookings. Um, no, anyway, so let's look at 16. I'm going to snip that in. Okay, so we're going to factor this. We're going to solve by factoring, and we're looking for two numbers that multiply to -14 but add to +5. So give that a try, please.
Rule 7 and -2.
Good. So that becomes x plus 7, x minus 2 equals 0. And so now this is the new part. You set each factor. So factors have an x. You set them equal to 0. So you set x plus 7 equal to 0 and x minus 2 equal to 0. What does that become when you solve those? What does x equal?
Or I forgot how to factor.
We're not factoring anymore. You just factored. You're solving these one-step equations. There's one step to solving it. You have to undo plus 7, you have to undo minus 2.
Or
How do you undo addition?
subtract.
Okay, so subtract 7 from both sides.
Mm,
Does
X
that,
would equal 0.
you're subtracting 7 from both sides. So 0 minus 7, what does that become? Not 0.
Mm, -7.
Okay, good. Same thing on the right here.
X
How do you undo
equal,
subtract?
it would equal 2.
Yes, there you go. So there's another step after factoring. You factor and then you have to set each factor equal to 0. All right, we're looking at 17 next. This time we're going to subtract 72 from both sides. X squared minus x minus 72 equals 0. So now we're looking for two numbers that multiply to negative 72, but add to positive 1. I'm sorry, negative 1. Let's see if you can come up with those numbers, please. How are you doing on this one?
I think I got it.
Okay,
So -9 plus 8.
perfect. That's the hardest part. It really is. Come up with those two numbers. So now you set each of these equal to 0. X minus 9 equal to 0. X plus 8 equal to 0. So what are the final answers?
So we're being x equals 9
Okay, and
and x equals mm, -8.
yes. Why do you think you have a little bit of uncertainty about that second one?
Um, because I saw the 0 and I was thinking of um,
All right, well, good job on that. I guess that does take care of everything that I've reasonably got access to. I mean, I can go look for more pictures, but do you think you could quickly send over a picture of number of page 3 or the next grouping of questions? Thank you for sending that over. By the way, when is your final exam?
It's next Monday.
Okay. Do you have an exam this week as well, or just next week?
So only for math, it's next Monday, but I have other exams for my other classes.
Okay. Yeah, you're busy.
Yeah.
Okay. We're going to do 19 before we do 18. It'll make more sense in a moment. Okay. 19 is a difference of squares problem. Difference of squares. So you've got to figure out what's squared minus what's squared. So this is what we're doing a little bit ago. Could you tell me what goes in parentheses?
16. 4.
Or gets you to 16. What about the k squared? How do you get back to that?
4k squared minus.
Well, no, it can't be 4k squared because when you square a square, it doesn't get you back to that. How do you, it's just 4k, just 4k. Okay, how do you get back to 49?
Um, 7.
Okay, so now tell me what goes in parentheses here. And if you need to, you can look back at one of those earlier problems what we wrote down.
So 4k minus 7.
Okay, and then
4k plus 7.
good. Now we set each factor equal to 0. So this is a little bit more involved than last time. But you should recognize how to solve this. You first undo the addition and subtraction, then you undo the multiplication division or division.
K equals 7.
4k equals 7. So how do you undo the 4 in front of the k?
Um, um,
How do you undo multiplication by 4?
divided.
Okay. So what does k become?
Um, Wouldn't it stay like that since
Yep.
they can go into each other?
Yep. You can just write 7 over 4. That works for me. All right. How about the other one? And the one on the right there? Could you solve that for us, please?
Mm, Wouldn't it be equals 0?
Nope. It's almost identical to what you did over here. I mean, there's like only one difference between the two equations, and that's this minus instead of a plus. So how did you move the minus 7 to the other side of the equation on the left here?
I added them
Why did you add? Why didn't you subtract?
because you did the opposite.
Okay, so maybe here subtracting 7 would be similar.
Mhm.
Okay. So it's not 0. What does it become?
-7/4.
Yes. All right, very good. All right, let's take a look at 18. All right. Um, so this problem, you've noticed by now that you actually want to get everything on one side of the equation. So you have 15r squared minus 5r equals 0. What is the GCF? What goes into both 15 and 5, and then r squared and r? What goes into both?
Um, 5,
Okay, 5 goes into both. What about the letter?
5R.
5r, good. We've done a bunch of these today. So tell me what goes in parentheses.
2R.
Nope. 15 divided by 5,
Sorry, 3R.
3r, okay. What comes next?
-1.
Minus 1. Okay, now this one's slightly different than the others. You said each of the factors, 5r, one of the factors, 3r minus 1 equal to 0. So let me know if you can solve either of those, please.
So I would divide the 5R.
Right? Yep. And what this means is you have nothing to share, but 5 people wanting you to share with them. What do each of them get if you have nothing to share?
It would be negative.
No, you have nothing to share. You have they all want pizza, but you don't have any pizza. So how much pizza do they get?
None.
They get 0. You have nothing to share. Sorry. Yeah, how about on the right here? What do you undo first? The multiplication by 3 or the subtraction by 1?
The subtraction by 1.
Okay. So this is a lot like the problem we were doing up here. 4x minus 7 equals 0. So tell me, what does r become?
So it would be, wouldn't it be 1/3?
Okay. All right. So that kind of that's kind of a break in the point there. Let's try one more here. Let's say it's 4x squared minus 1 equals 0. This is a difference of squares. What squared gets you back to 4x squared? What do you square to get back to 4x squared?
2x.
2x. And what do you square to get back to 1?
1.
1. So give me what this becomes in parentheses
It
when you
would be
factor. 2x minus 1, 2x plus 1. And then set each of those equal to 0 here. Could you solve the one on the left, please?
would be 1/2.
Okay, and the one on the right becomes -1/2. All right, so I know we're meeting tomorrow at I think 11. Go ahead and stop right there.